This question actually involves something called mass points. So I think we talked about mass points before. So hopefully you remember. If you don't, then like hopefully this question will like refresh your memory on how it works. So a triangle is partitioned into 3 triangles and a quadrilateral by drawing 2 lines from vertices to their opposite sides. The areas of the 3 triangles are 3, 7, 7 as shown. Want to know what is the area of the shaded quadrilateral? So before we get like started, like we have to first like talk about like something important, which is that like suppose you have like a triangle. And this is a very important fact in math in general. Like suppose you have like some arbitrary triangle. And suppose we kind of drew this line. Like suppose we drew this line. And let's suppose that like the area of both of these triangles is like 10, right? We created 2 triangles and both of the triangles have area 10. So an important thing to know from this is that you can actually conclude, like if you were to call like this length A and this length B, we know that the height of the triangle is H, right? Let's call the height of the triangle H. Then the area of this like red triangle here, right? The area of that red triangle is going to be 1/2 base times height, 1/2 A times H, that's 10. And similarly, the area of like, let's say this green triangle, again, the base is B, but the height is still H. So the area is 1/2 B times H. And we know that like this has to equal 10. So if you were to like divide these 2 equations, you can kind of divide them and you get A over B is equal to what? So in other words, you get that A equals B. So this is like a very like important like math thing to know, that like if you have a triangle and you like kind of like slice it like in half, if it splits the area of the triangle in half, then the 2 bases have to have equal length. So in this case, this length has to have the same length as that length. And this is like a very useful strategy, and you can kind of extend this result, right? You don't have to have equal areas. Like if you have like, for example, if this area is 3 and this area is 7, then you can use the same logic and you get like, if you call this A and this B, then you can get that the ratio A over B is equal to 3 over 7. So, and again, the reason that follows is because these 2 triangles all share the same height. If they don't share the same height, you can't do this. But in this case, if they do share the same height, then the ratio of the bases, like A to B, is just the ratio of the areas. So this is like a very important like concept to know. And again, let's quickly review like what mass points are. So like mass points are like, remember if you have like a seesaw, right? So like suppose you have a seesaw, and if you have like a fulcrum here, let's say this distance here was like 1 meter and this distance here was like 2 meters. Now suppose like you put a 1 kilogram object on this side of the seesaw. Then you want to like balance out the seesaw, right? So you want to know like how heavy of an object you have to put on the other side to balance it out. So the logic is like, this distance here is twice the distance here. So 2 is twice 1. So in order to balance stuff out, this length here, or this mass here, has to be twice the mass on the other side. So in order to balance it out, you have to put a 2 kilogram mass on the other side. So this is the foundation of mass points, that if you have the ratio of lengths, you want to like balance things out. So now we can like return to the original problem, which is like, you have this triangle here. And we have this triangle, and we draw that length and we draw like that length, and we're given that like the area of the triangles are 3, 7, and 7, and we want to find the area of like this shaded quadrilateral. So the idea is, first, like quadrilaterals are kind of hard to handle because like like quadrilaterals are not as easy to deal with. So something natural to do might be to take this quadrilateral and split it into 2 triangles. So you get a triangle this side, a triangle this side. So all we have to do, instead of finding the area of the quadrilateral, we can find the area of the 2 smaller triangles and then add them together to get our final area. So again, remember like how mass points works, right? Or first, let's do area ratios, right? So like, so basically like we see that like we have 2 triangles of area 7. So we have 7, 7. So we just talked about that, like if the triangles have the same area and they come from the same triangle, right? Then the ratio of the bases has to be the same. So that tells us that this length has to equal this length. So those two lengths has to be equal. So we kind of use mass points, right? Actually, let's first take a look at like this triangle over here, right? So let's take a look at this, like this green triangle. So we notice that like the ratio of the areas is 3 to 7. So by the thing we just talked about, we know that like the ratio of the bases also has to be 3 to 7. So this length has to be like 3x. This length has to be like 7x. So remember, by like our mass points argument, if we have like a 7 kilogram mass on this point here, then to balance out like this seesaw, we have to have like a 3 kilogram mass over here in order to balance things out. And how mass points works is like, we should have talked about it here, but if you have like a 2 kilogram mass here, 1 kilogram mass here, then if you want to find the mass at like the fulcrum, you would just add the two sides. 2 plus 1 is 3. So in this case, if you want to find the mass of like this point here, then you do 7 plus 3 and you get a mass of 10. Okay, so now like we can like go back to like this triangle over here, this blue triangle. Notice that these have area 7, so the ratio of the bases has to be the same. So, you know, this length has to equal this length. So that tells us essentially that like the mass on here has to be the same as the mass on here. And their total mass at the fulcrum is 10. So if we split that in half, each of these has mass 5, we can say. Okay, so then now we can take a look at like, you know, we can take a look at like this seesaw here. We see that this has a fulcrum of 7. One side has a mass of 5. Then the other side has to have a mass of 2, because 5 plus 2 is 7. So if you were to do that, and similarly, you can see that this clearly agrees, right? You have 2 and like this 2 here and this 3 here also add up to this 5 here. So that's like a double check to make sure our mass is correct. So to find like the area now, we can again go back to our area ratios. So the idea is like we have basically, notice that like this triangle here, we know that like the mass is, this mass is 2, this mass is 5. So by mass points, we know that like this length, if this length is 5x, and this length here is 2x, right? Just by mass points. So now we know that like this red triangle has 5 halves times the area of this triangle, right? Because the ratio of the bases is 5 to 2. So the ratio of the areas is 5 to 2. So since the area is 3, then the area of that triangle is 3 times 5 halves, which is 15 halves. And we can do a similar thing on the other side, right? We know that like here, if this length is 3x, this length is 2x, right? Because the masses are 3 and 2. So the ratio of the length is 3 to 2. So if the ratio of the lengths is 3 to 2, since they belong, this triangle belongs to the same triangle as that triangle, the ratio of the areas is also 3 to 2. So we do 3 halves times 7. That would give you 21 over 2 for the area of that triangle. So then the total area of that quadrilateral is 15 halves plus 21 halves. And then you would get like a total area of 18. And that would give you like choice D, which is the right answer.